Today we're going to talk about function tables. And function tables, we see them in our textbooks and on tests and such, and they look like this, and they look a little bit arbitrary and artificial, like they're just existing for the sake of a textbook. But actually, they exist to organize information that we see all around us in real life. And so all of these different lines that we see here are exploring different situations and their results. So today we're going to look at how the function table is organized and how it helps us organize information and understand it better. First situation, we're going to look at an example with Abby and Bill, a brother and sister. Abby's the little sister, and she gets an allowance, but she's old enough to get an allowance. But Bill is older, and so he will always get $5 more allowance than Abby does. Their parents just think that's the reasonable rate. So Abby, we're going to represent Abby's allowance with A and Bill's allowance as B. Those are variables we're going to use because we don't know how much their allowance is. So we can know that relationship between them, though. How do we compare them? In math, we're always looking for the relationships between things. And we know that Bill's allowance is always going to be Abby's allowance plus $5 more than that. So that's Abby's plus 5. So those are the situations that exist. So in a function box, they have a rule at the top, and a rule is showing what that relationship is between those two things. So in this situation and others, it's putting more, we can think of it as if and thens. If this situation exists, then this situation exists. Kind of a cause and effect relationship, or if one's, then the other. Sometimes we think of them in this situation as Abby's allowance and Bill's allowance. It's not necessarily a cause and effect, but how they're related to each other. Sometimes you'll see it, especially with younger children. For students, they'll put an in and out. If it goes in, if this number goes in, what number would come out of that situation? But it's really the relationship between those two situations, so that you can know what the situation is, whether you know one or the other, if you know how they're related to each other. So the rule can be written like this, with addition written out in words. Sometimes they don't write out the situation, and they use the symbols for how they're related. Sometimes they include the variables. They can say, oh, in this situation, Abby's allowance plus 5 gives you Bill's allowance. And sometimes we have to remember that this equation, this equal sign, means that the value on both sides of that equal sign is the same. So we're used to seeing it a little bit like this, but sometimes students are thrown off when we just reverse those, and I'll show you that one. If we see B is equal to A plus 5, it's the exact same relationship. It's just written with those switched around. So this function box is going to serve to show us how we can make sense of possible scenarios with Abby and Bill's allowance. So in our example with Abby and Bill's allowance, Bill gets $5 more. Our variables showed us how they compared to each other. So in this situation, our rule is going to be that Abby is, on the in or out, or the words, that Abby's situation is going to be on this side. So whatever Abby gets for her, and sometimes it helps to put people's names in here, even if you're trying to think about the understanding, and Bill's allowance over here, or A is the in and B is the out. And A, our rule is going to be that we're going to add 5 to whatever it is, and that will give us the in and the out. Oh, I want to show you one more thing. But for example, we know if Abby's rule is 1, or her allowance is $1, then Bill's allowance is $6. If Abby's allowance is $2, Bill's allowance is $7. if Abby's allowance is $10, Bill's allowance is $15. And that can absolutely be the case. But sometimes we have this situation where we want to we don't know Abby's allowance, but we know what Bill's is. And in that situation, I'm going to clear some of this off. In that situation, if I know that Bill's allowance is $15, then I know that I added 5 to Abby's. So if I subtract 5 from Bill's, I'm going the other direction, then I know that Abby's allowance was $10. If I know that Bill's allowance was $20, then I can subtract the $5 that I added in and reverse it and go back, and I know that Abby's allowance is $15. So whether we know Abby's information or whether we know Bill's information, the important thing is that we can use this table and reminding ourselves of this relationship to help us understand what, if we know either one, we can find the other if we know that relationship. Let's look at another situation where it's not adding and subtracting. Let's go ahead and look at the next page where we have a car. I know this isn't the spiffiest looking car. I'm not great at drawing cars, but I'm looking for cars right now, car shopping. So each car has 4 tires. Every car I've looked at has 4 tires. And in this situation, I want to know how many tires are in the whole parking lot full of cars. They've got a whole bunch of cars there. So I have to think about, what do I need to know? And in this situation, I need to know the relationship. I need to know the relationship between cars and tires. And we all know that already, that we need to know how many cars are in the parking lot. So if I find out how many cars are in the parking lot, then I'll know how many tires I have. So the relationship of cars to tires is for one car, there are 4 tires. And that shows a ratio. That's a standard relationship. Every car I see has 4 tires. So that ratio is 1 to 4. So that's their relationship. So when I want to put that type of thinking into a function box, I sometimes keep track of it in a regular table, and students are comfortable with this. Cars and tires. I can keep track of those, cars and tires. But a function box also shows me the relationship between those, or the rule, they sometimes call it. The tires is equal to, how many tires it has is equal to 4 times the number of cars that we have. Well, sometimes I might want to write it differently. So instead of writing it this way, I might write it this way, where I write 4 times C is equal to T. It doesn't make a difference which way you write them as long as they show the relationship that's there. So the function box is complete now because it's just like a table that shows us the relationship. And now if I know if I have 1 car in the parking lot, I'm going to have 4 tires. If I have 2 cars in the parking lot, I'll have 8 tires. I could continue this path up there, or I could just use my relationship. If I've counted and there are 15 cars in the parking lot, then I know that 4 times 15 is 60. There are 60 tires. So that shows me the relationship. If there are 100 cars in the parking lot, there are going to be 400 cars. I also know if for some reason someone has counted that there are 80 tires and I need to go back and figure out how many cars there are, well, I'm going to divide by the number of 4 because I multiplied by 4 going this way. And so if I'm going the opposite way, I'm going to divide by 4. So 80 divided by 4 gives me 20 cars. If I have 60, let's pick about it. Yeah, 60 cars over here and I didn't know how many there were, I divide by 4 and I get 15. So whether you know cars or tires, you can figure it out if you know the relationship. So that's the important thing about knowing the relationship between cars and tires and how we can go either way from those. So function tables, in a nutshell, show us the relationship between two pieces of information. They show that relationship to us in a table format where we can keep track of 2 or 3 different items, but usually 2. We also show different possible situations. Sometimes we can solve it exactly. Sometimes we figure out what multiple possibilities are for this situation. So function tables are actually used all the time in life. If we're buying fruit by the pound, if we're buying gasoline by the gallon, if we're trying to figure out how many one box of cookies holds 24 cookies, like I was planning a large event lately and I needed to plan how many cookies, those relationships can be shown very well in a function box. 8 commercials for every one TV show. How many commercials will I have watched in the 3 hours I watch TV? Or what about if I watch 5 hours of TV every day? How many commercials am I going to see? So anytime we have a distinct relationship between two things, we can look at some possible scenarios and some possible situations and use a function box to help us understand them. So have fun finding some functions in everyday relationships and look at function boxes as a not an artificial thing, but as a true, meaningful representation of what we see in life.